Right. Hi there, I'm Hao, and this is just another video of me solving random code problem. So given n pairs of parentheses, write a function to generate O combination of a well-formed parentheses, right? And this is an example. So they have three pair here, right? We have O combination here. So we can just try O combination, right? So let's say you can start out at this, the opening parentheses, right? And you can have two options. To either pick the opening or the closing, right? So when we, because there are two options, right? So this is and the path will be the depth will be n, right? So this will be 2 to the n sometime. But actually 2 to the 2n, but we don't because we want the pair, right? So uh 6 characters, right? 3 open and 3 close, but we ignore the constant, so it's 2 to the n. So when we want to add the open or the close. So for example, right, if n is 3, then we know that the maximum number of open paren is 3, right? And the maximum of close is 3, right? And we always want the close to be less than the open, right? Right? Because if at any point in time, if the close is equal to the open, right, the number of close is equal to the open, then we don't want to add the close, no closing parentheses anymore, right? So our condition can be if the open is less than n, right? Because we want n open parentheses, right? If open is less than n, then add open, right? And two, if close is less than open, right? Then we can add the close, right? If these two, if either one is so if number two is violate, then we don't add the closing parentheses. And if the first one is violate, we don't add the opening parentheses, right? So first of all, right, we have, what do we have? We have zero. So close, let's say close is equal to 0, right? Or just never mind. Okay, so here you can just look at here, right? Before we start, we don't have any opening parentheses, right? So open would be less than n, right? Zero is less than n. So we add one here, right? We can also start with a closing parenthesis, but that is not valid. Why? Because close has to be less than open, right? If open is 0, then we cannot add the close here, right? Because if we add the close, this will be valid, right? We only add the close if the current number of closing parentheses is less than the opening parentheses, right? So that is just not valid, right? Same here. We can just keep going, right? Let's see. So we can either pick open or close, right? In this here, we can pick open or close because the total number of open is less than n, right? So there's no problem here. So this is not valid, right? We don't want to add because if we add the opening parentheses, the number of opening parentheses would be equal to n. Would be greater than n, right? So if the number of open parentheses is already equal to n, then we don't want to keep iterating, right? We don't want to keep going. We just stop here. Let me just delete that. Okay, same for here. We can just so it's only one option now, right? It's open, 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 and close, right? Open, 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 and close, and open, 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 and close. This is 2, closing, just 3, right? And we stop because the number of closing parentheses is already equal to the open. We don't want to add more, right? So we stop here, and this is our one of our results here, right? For example here, right, we can have two cases. This is open, right? It is close. So we have 1, 2, 3 open now, right? So we have to do close now because we already have 3 open. So there's only one option left, right? Close. So this is another valid solution, right? Then for here, we can have two options, right? Open. This one would be close, right? And it is not valid, right? Why? Because open is 2, right? And close is 2. And we only add if close is less than open, right? So we're not gonna go here. There's only one option here. All right. Same for here. Because the opening is already 3, right? The only option left is to close. And this is also another valid solution. Right. Same for here. Maybe make some space here. We have 2 choices here open. Right. This is not valid, right? Because we have one open, one close, so it's only one option. Right. Keep open. So this one we can close, right? So this one only one option now. Close, right? And then close, right? So this is another valid solution. Same for here. We can open, right? Only one option. We cannot close because we already have 3. Okay, so this is another valid solution, right? So how many do we have? We have 1, 2, 3, 4, 5, right? Which is this one is this one. This one is this one, I believe, right? This one is this one. Yeah, this one is this one, and the last one is this one. Okay, so this is how like we get our solution, right? So at each point, so this is a problem, a backtracking backtracking problem, because like usually when we do backtracking, we would pick something, right? And we undo, we pick something, and then we explore that solution, that path, and then we go back and then un undo it, right? But in this case, we don't have to. We just have to know because we have the condition. Uh, we know when and when not to add uh the opening or the closing parenthesis, right? We know when to stop. So let's give it a try here, right? We can have our results array here, result, right? And we can like import result here, and we can DFS of 0, and then let's see, what do we do? We want what do we want to keep track? We want to keep track of the closing parentheses and open parentheses, right? So that is 0 and 0 and 0. And we also want to okay, let's just write out the function first. So parse DFS equal to open and close, right? Right, so if open is less than n, right? Then we keep going, right? DFS of open plus one, and then close, right? We want to increase the number of opening parentheses if the number of opening parentheses is less than n. Right, same for here. If low is less than open, then we want to explore, right? Open and then close stuff plus one. Right, we want to add the closing parentheses. So what is our base case here? Our base case is when our base case for our balanced solution is when the length of n, right? The length of the string. So let's call it string, the length of string. So here, if the string length is equal to 2 times n, right? In that case, we will resolve the put the string, right? So if we ever reach the string length of 2 times n, which is our last line over here, right? So we know that we have reached a valid solution. So we push the result, we put the output into our resulting array, and we can return it at the end, right? And if we don't reach a valid solution, we're just gonna like return only file here at the end, right? It's like we just don't do anything with the invalid case. We just ignore it and keep going. And I think that's it. Am I missing anything here? We have our base case. We have our recursive case. And yes, we forgot to add the string, right? It would be open, and then it would be string plus floats, right? All right, let's give it a try. Accept it, submit, and it worked. Thank you for watching.